Okay, I think the first session we discussed about the features of Go, and we also discussed about how do you run your Go application. That's what we did in the first session. Let me create a simple, let me create something called a stub so that I would always get the example from this. I want to explain you the second one. I want to explain you a couple of things. One of them is how do you really build your application and also variable creation. We will discuss about it on the process rather than spending a lot of time on building and building commands and etc. Okay, so let me create a stub with variables. We go to variables, we go here. So to create a variable, generally, you need to understand the memory model. That's very, very important. Okay, if you want to create a variable, it's not just about the variable. You need to understand the memory model of that particular application, general process memory model. I will discuss about the memory model little later because it's very imperative to understand the memory model. Unless until we understand the memory model, we really cannot understand the variable creation. It's not just creating a variable. Say that you would like to optimize the application. You say that you would like to write the application in such a way that it has to properly take the memory. We need to understand the memory model. Generally, to create a variable, so if you look at variables, we can talk it we can talk it as numbers, we can talk it as string, we can talk it as boolean, special types. When you really look at numbers, that means it could be integers, it could be floating point numbers, everything we call it as numbers. We have something called integer, uint, int 8, uint 8, int 16, uint 16, int 32, uint 32, int 64, uint 64, float 32, and float 64. These are all numbers. You know the calculation, generally integer is 8 bytes on 64-bit machine, 4 bytes on 32-bit machine. We know that most of the processors are 64 bits, so people generally say these two are 8 bytes. Uint means unsigned int. That means there are no negative values. Sorry, I'm having some muffled voice. Sorry for that. So uint is unsigned integer. Okay. Int 8 means 1 byte. Int 16 means 2 bytes, and so on. String means collection of, I just put it as string. It's a data type. What is this data type? Collection of bytes. We will discuss about why collection of bytes, why not collection of characters. Okay. We will discuss why it is collection of bytes, but not why it is not collection of characters. Boolean means just bool, true or false. There are some special types which is called any. Any is a special type. or we can also think as empty interface. I will talk about this as well. How do you create a variable where num1 is integer? There is a zero value for every variable. What is called a zero value? If you don't assign any value, automatically zero is given for numbers. Let's say where float1 is float32, where num2 as uint8, where ok1 is bool, where str1 is string. These are all variables, but we have not assigned any value to these variables. See that we are not assigned any value to these variables. So there is something called zero value. Zero value means if you don't give any value, it gives some value which is called zero value. So the zero value for a bool is false. The zero value for string is empty string. That means this. Okay, we call it as zero value. I want to print the variables. Earlier I used print line built-in function, but now I would like to use fmt.println. It's from a package called fmt num1 float1 ok1 str1. The moment I use the package, automatically it gets imported, which is called standard package. Standard package is nothing but it comes with Go installation. I will discuss about that going forward. I'm not explaining you the whole theory at once. I'm trying to, you know, put it into installments and then trying to explain. If you really look at this, you find that there is some error. Declared and not used. Num2. In Go, if you declare a variable, you must use the variable. If you declare a local variable, you must use the variable. Otherwise, it would give an error. That's what exactly you're doing. At least print the variable. You see that all the zero values are created. There is zero, there is zero, there is zero, there is false, and probably there is a empty string. If you keep it over here, you understand empty string because it would give you additional space. You see that additional space is given because it's an empty string. It doesn't create a space, but every variable with a comma would create a space in Go. Okay, you see that these are all the variables, but we have not assigned any value. All these variables are mutable. Even though there is a zero value, you can go and then assign a value as and when required. See that these are the values that we have given. Fine, there is nothing much in that. There is another way how you can assign a value is where num3 is integer equal to some value, where float2, which is a float 64, with some value. There is a range for all these variables. Again, we declare the variable but not used, so that I simply use num3 plus plus float 2 plus plus, just using increment operator, unary maybe increment operator. Probably I can use decrement operator. Again, I am just printing, not doing anything. Num3 comma float 2. You see that fmt.println prints, but it is algorithmic printing. I don't want that. I want actually proper floating. I think base 10 kind of a printing this is. Logarithmic, not algorithmic, sorry. I want a proper print. This number is very big to be shown. So what you can do is fmt.printf, you might have heard in C language. For a change, percentage %d, I'm talking about this, is a decimal number and percentage %f is a floating number. Number 3 comma float 2. But percentage %f, I want to give only 2 decimals or 3 decimals, 0.3. Should know the difference between these two. This is a developer friendly print line with log based logarithms. You know that logarithms based print. This is with proper decimals. If you don't give this, it would print every decimal. Fine, that's fine. So you understand there is a way to create a variable. These are all local variables, local to main. I will talk about this in detail. You can also create a variable like this where num num4 equal to some value, where float 3 equal to some value, where str2 equal to some value. You can see that. This is called type inference. That means you're creating variables, but you're not giving the type. You're not telling what type the variable is. So based on the right hand side variable, it automatically gives the type. It gives the type. This is integer. By default, it gives the biggest size of that float 64, but not float 32. This got to be the string where OK2 equal to true. This got to be Boolean. So since we have to use the variable, maybe I'm using just print line statement, fmt.printf. And one more thing, printf would not print to the new line. You need to give /n like in C language. Printf, I want to print the variables. Number 4 is percentage %d. Float 3 is percentage %f. Sorry. str2 is percentage %yes. OK2 is percentage. You can give v means any kind of value. I got to give a new line after the statement. I can give num4 float 3 str2 comma OK2. So you formatted and then printed like this. Okay, fine. So this is called as type inference. What does it mean? Based on the right hand side. One more thing you need to understand, type inference on numbers always give you the highest. That means if you assign a value, let's say that I create a variable where num4, you can also create a group of variables. Num4 equal to 10, float 3 equal to 1.35, probably float 4. I have two variables. It's a group of variables. Instead of putting var everywhere, you can create like this. If you use fmt.println, probably num4 is num4, and I know that floating point number would give the float 4. Sorry, you can also create like this float 4. I purposely write different ways so that you can understand. Float 4 is float 4. Probably num5, num4 might have been used. You see that these are very small numbers. You want to know the type of the variable. fmt.println type of num5. There is a package to tell the type. The package is called reflect.type of num5. Reflect is a package. Similarly, I want to know the type of float 64, float 4. There is another way to get the type as well. It's not only this. You can use fmt.printf type of float 4. You can use percentage %t comma float 4. Percentage %t is gonna give you the type. Percentage %t is gonna give you the type. You can use either this reflect package, reflect.type of, or float 4. Anything is fine. So how do you get all the help like this automatically? Otherwise, you have to write. You need to go to the extensions. Please go and then install Golang extension, Go programming language. This one is very important. Rich Go language support. Earlier it was by Microsoft, but I think they handed over to Google. Go team at Google. They get that. You have to install this extension. Whoever is very beginner to go, please install that. Others might have installed already. Not only that, you need to install a couple of tools that work with Go. You can click on control palette, sorry, command palette. Okay. I'm using MacBook so that it is a MacBook uh, shift Mac command key and then P. I use shift command key and P. It would open me the command palette. Here just write Go install or update tools. It would give you a couple of tools. Select all the tools and install them. They would be installed from the internet. These tools are for testing purpose. There is a language server that would whatever you write in Go, how do you get the color codings? How do you automatically these things come? If you create a variable, let's say language server, I tell you, you create a variable where num6 equal to some value, but you don't use the variable, automatically the underlying some declared or not used. There is kind of a static checker come into the picture. All these things are part of these tools. You need to install them. Earlier they were 11, later they merged and then they make it as 7. I think even they merged further, they make it as 5. This is for the debugging purpose. This is the language server. This is the Go playground. This is the implementation block. If you, it would help you to implement some kind of a interfaces, etc. Okay. This is Go test, which is used for the testing purpose. It's a playground. Playground is whatever you go here. If you go and then type Go playground, the same thing, whatever you have here, it would be, you can write in one work here. The same thing you can also get inside. It's not required for us, but I'm just telling you. Okay. This got to be an error. However, I'm not using this. You see that the type of num5, even though you give a small value, the type is integer. What is the size of integer? The size of integer is 8 bytes. Let's say the type of num5 and then you can say size of num5. Since num5 is a int int value, you can use I think unsafe dot size of num5. This got to give you unsafe is a package. From the unsafe package, you can get size of a variable. Automatically unsafe come. If you don't, you have to write it. So what I do, I say go run. You can see that the type of num5 is integer, size of num5 is 8 bytes because I'm running it on a 64-bit machine. The type of float 4 is float 64. So even though the value is very small, if you use type inference, it automatically takes the biggest value, particularly for numbers. String and all, there is no problem. Boolean, there is no problem. Absolutely, there is no problem. So this is what basically variables are. There is another way to create variables, which we call it as a shorthand declaration. That means I just create variables colon equal to some value, colon equal to some value, colon equal to is nothing but shorthand declaration. In fact, you can also create okay b comma c. You can create any value variables. True. So a is integer, b is float 64, c is boolean. You can create like this group of variables. So I'm not doing anything, just printing a, b, c. Here a and b and 3 are three different types of variables. You cannot do the shadowing. You know, some programming languages, particularly Rust, you can recreate the variable, but Go doesn't support. A is already decided as integer. You cannot reshadow it. A equal to, even you cannot create a variable as well. This is also not accepted. I think, yeah, JavaScript, you can create a let variable again and again with the same name. Rust also you can do. You do shadowing. You recreate a variable. It doesn't accept. Basically, Go doesn't accept. Already a variable is created, which is an integer. You cannot recreate a variable. If you want, you can create a block so that this variable would become the local variable for that particular block. And then you right now I'm doing is print line of A. It's a using built-in function. This is a different thing. You're creating a new variable within a different block. Different block is different memory region. It can understand. It's a different block. It can understand. Okay. It can understand that you have created a variable which is different in a different block. But within the same block, it's a stack frame. I'll talk about that. You cannot recreate the variable. Within a block, yes, you can. So this is called a shorthand declaration. Shorthand declaration means you don't give where, you don't tell the type, but based on the right side value, you can see A, B, C. These are A, B, C. You want to print A, B, C. It would give you the values. A is this, B is this, and C is this. This is called as shorthand declaration. Okay. So we see that these are all created within main or within a function. Remember that. That's very, very important to understand. I'll talk about it. You can also create constants. Let me create another example. You can also create constants. Probably stop. I will remove this. Keep the stub as clean so that I'm copying from the stub. You can also create a constant. Constants are pretty tricky in Go. So far, what are the variables that we have created in Go? They are all local to main. I can also create a constant pi equal to 3.14. You can also give the type. Probably you can give float 32. That is fine. You don't need to give the type as well. It could evaluate. Let's say const. So this is the constant const max comma minimum. Let me put it as capital letter pi max comma minimum equal to maybe some value comma some value max and minimum. Otherwise, you can also create a group of constants. Anything is fine. These are constants. Can you change the value of a constant? Can you create an expression? You know that expressions, evaluations, there are mathematical operator, arithmetic operator, there are boolean, sorry, there are comparison operators, and there are logical operators, there are bitwise operators. We have a couple of operators over there, right? Can you perform an arithmetic operation with a constant? Let's say that I want to do max plus plus, print line max. So this is not possible. Maybe constant plus equal to 1. You are reassigning the value. You cannot reassign a value to a constant. You cannot reassign a value. So expressions are possible. The answer is yes or no. Why I said yes or no? Expressions are possible if the right side, the operands are also constants. You are reassigning the value. But what if while creating you want to create an expression? Let's say that I would like to create thick is int 1. I just purposely created. There are different ways to create. Let's say minute. Okay, let me put it as second equal to 1. Minute equal to second into 60 into, okay, let me put ticks equal to 60. Second into ticks. This is an expression. Yes, you are doing something at the right hand side. Is it possible? Yes, it is possible. As long as the right hand side are also constants. It's a constant. This is a constant. Even if it is not there, this is a constant. 60 is a constant. It is possible. But this is not possible. Let's say I would like to create something like this. Minimum minute equal to colon equal to 60. I want to create another constant, which is called constant hour equal to minute into minute. I'm going to get it in terms of seconds, minute into minute. This is not possible. The reason is it is a variable. So you need to understand when variables are created. Variables are created once your application start running. Variables are assigned once your application start running. But constants are evaluated, constants are created or assigned when you compile your application. So you need to have the clear cut on comp time versus runtime. So constants are comp time variables, compiler time variables. That means they are all evaluated at time of compilation. But here I can do second, sorry, hour equal to minute into ticks. You have a day equal to hour into 24. We are all getting everything in the form of seconds. But this cannot be assigned here. This cannot be done. This cannot be done. It's not possible. And should we really use them? No. If you don't use constants are also fine. It doesn't care. But variables that are created within the scope, let's say, can you create a global constants? Yes. You take it, you put it over here. These are all the constants. These are all the constants for the entire package. What is the meaning of entire package? You can use them anywhere. What is the meaning of anywhere? I can go and then create a file called greet.go, which is also from the same package. It's not necessarily that everything should be written inside main. You can split it. fmg.println hour equal to hour. Import fmg. I'm sorry. Function you have to write get seconds of get hour seconds print hour seconds. I put it over here. I put it over here. This is a function. So it is written in different file, greet.go. But what is important is both of them should be in the same package, which is called main. So I go here, I can call it print our and all. This is a function. How can I call it? Because it's in the grid.go. How does it understand that it is in the grid.go? It can understand if it is written here. Let's say that I cannot print the same thing with pi. For example, print pi. I put pi. It doesn't get because it's a constant, but it's a local to main, which is not global. Global constants are different everywhere. The entire package can use, but local constant can be used within the local. You cannot use here. Can't use pi because it is a local const which is local to main function. That's a different. But this is the global const above main so that anyone can use it. So, couple of things. What are constants? Constants have to be evaluated at comp time. Can I use the expressions? Yes, you can use. Let's say that for your understanding, for the sake of understanding, a comma b equal to maybe 10 comma 20. I create some constant, some c equal to, for example, a plus b divided by 2 into a b minus a plus maybe 3 plus a modulus b, which is going to give you the remainder, and etc. You see that, and nothing, not does not make sense. But can write expressions. Make sure that all the operands, a, b, all the operands are constant. 3 is a constant. Let's say plus or plus some value. This is a constant. Or plus day, sorry, plus day is a constant. These are all constants. It's an arithmetic operation, but when it is evaluated is very important to understand. When is this evaluated? Not at runtime, at compile time. That's very important. This is evaluated compile time. Your compiler has got a special facility to deal with constants. I got to print, okay, print line max. This is evaluated by the compiler, not by the runtime. Okay, you can do go run. You got some value. Where do you get the value? This value is evaluated at compile time. What is the operator precedence? We'll discuss about it. Bracket has got the highest precedence. So if I give bracket, this is evaluated first. What if there are two brackets? Two brackets are there. The evaluation starts from left to right. It looks for the brackets. Parenthesis has got the highest precedence, followed by into or divided by, which both has the equal precedence, followed by plus or minus. Both has got the equal precedence, and the last precedence is equal to operator. You might have studied in your school or college. The same thing, but this is evaluated at compile time when you compile your application, not when you run your application. You're printing it when you run your application, but the value of some C is already there inside the variable called some C during the compilation. During the compilation, this is very important to understand. Okay, I'm just trying to explain you what constant. I said this is not only for Go. This is for almost all compiled programming languages. There is nothing special with Go. This even Rust does the same. C++ does the same. Java does the same. C# does the same. This is common. Constants are evaluated at compile time. Can't I use constant with runtime? Yes, you can use. You want to do with the constant number equal to 10. Okay, number equal to sexy into 10. Yes, you do that. But what is called sexy? It should be a constant of integer type. What if it is not integer type? Let's say the whole expression I put greater than 1000. The whole thing gets changed. The moment comparison operator comes into the picture, this is no longer integer, this would be a boolean. So this expression doesn't work. What is a true or false into 10? What doesn't make any sense. So what operator that we have used is very important. Arithmetic operators always give integer, arithmetic operators are applied on numbers. Simple thing. Does it make any sense? Some C1 equal to true plus 10. Does it make any sense? True is a Boolean operator plus 10. You're trying to make arithmetic operator. So only some data types are allowed to do arithmetic operation. If you give 10 plus 10, yes, it makes sense. If you do true plus 10, it doesn't make any sense. Similarly, the moment we are given as greater than operator, this sum C is evaluated everything since greater than, less than, and all has the least precedence. After evaluating everything, it checks with it just compares. Let's say I give something like this and true. And is what? This is a logical operator. Again, logical. So you need to know four kinds of operations. Arithmetic can work only on numbers. It is going to give the number type. Logic comparison operator greater than, less than, not equal to, which is going to give again the Boolean. Logical operator and or not and all, they are going to give the Boolean. And there are bitwise operators. Bitwise operations are quite different. They give you again the numbers. Okay. So this is what basically about constants. Just want to give you some kind of information about what constants are. Okay. Couple of things we discussed here. You can split that code into different files with the same package name. You can call the variable that is created in another file into this file as long as the variable is globally declared. Now, I go back, I create variables. You can also create a global variables. Let's say where global equal to 1, shorthand declaration. Where global equal to 1. So global is a package level variable. Interestingly, I will tell you what it is. What does it mean? It can be used anywhere in the package. Let's say global plus plus print line global. Let's say go and create some other file a.go package main function. Okay, incr. I got to increment global plus plus. And every time I say incr, and INCR, I print global. This is very dangerous operation in fact. You might have heard something called thread safe operation. Thread safe means multiple threads can access the same variable concurrently. Right now we are not using any threads, but it's a very dangerous operation. I will talk about that later. So global variable or package level, the name can be anything. You may put it as a counter instead of global. The name of the variable of is any can be anything. It looks pretty simple, but it is not. I tell you the reason. If you really look at any programming, any variable creation, that means what happened? You run an application. When you run an application, a binary is created basically. The binary has got a process is when you run it, a process is created. A process contains four kinds of memories, which is called code or text segment, data segment. It has further divided into, I think, BSS segment and RO segment, etc. Stack memory and heap memory. Four kinds of variables are created. So whenever you what this code or text segment contains, the code or text segment contains the entire binary is loaded into this memory. So how much memory that the process gives for the code or say text segment? The memory that is given by your process is equivalent to size of your application, size of your binary. How do you create binary? Automatically it creates binary. When you say go run, it creates binaries internally. We saw that go run work main.go. It creates binary. Sorry, because it's split into two files. It creates binary here. It builds, it creates binary. Let us say I want to create the binary by myself before going to go this. I want to create the binary by myself. How do you do is you need to build your application. You need to build your Go application. How do you build your Go application? Go build dot. Dot means there are two files. Instead of giving main.go and then a.go, I just give dot. What it does is it builds your application. Building your application is nothing but generating a binary. It generates a binary. You can see the binary. If you try to know the size of the binary, sorry, it's a Linux command. It's 1.7 MB, the size of the binary. This size of the binary is 1.7 MB, which contains your runtime, your garbage collector, Go runtime, Go garbage collector, and also Go symbol information we'll discuss little later. Everything into 1.7 MB. So what is the size of this segment is 1.7 MB. That means the 1.7 MB is loaded or maybe little additional because we don't know the entire how much it does it add anything, but 1.7 MB is the size of this segment. So the size of the text or code segment is varying. It depends on the binary size. Okay, you can also create a binary with your own name. Own name. You can give output, maybe app. This is going to create the binary with the name called app. Okay, if you want to create with your output name, output is app also same size. There is nothing. You can see app is also 1.7 MB. Demo is also same. Both of them are same. I just renamed it. In fact, the output command would rename it. So whatever the application that you are going to run, it is loaded into text segment or code segment. If you create any global variables, there are two types of global variables and constants. You see that there are three kinds of variables here. One is called counter equal to 1. I assigned a value. One is called const pi equal to 3.14, which is a constant. Other one is unassigned. These three variables are stored in data segment. These variables are also called as static variables in other language. That means these are all stored in RO means read only. Constant is in RO. Okay, global variables, global or package level variables, constants are allocated here. These global variables are also called as static variables in some programming language because they are available across your application and you don't need to allocate any memory for them because the memory is allocated in the data segment. And data segment is a segment where once it is initialized, it would never be deallocated. So what is the difference here is these two are allocated at comp time when you compile your application. These two are allocated at runtime. So coming to the other one, let's say I create a variable a comma b equal to 10 comma 20. Let me a comma b ok comma str true comma hello world like in Python. I created four variables. Where these variables are allocated? These variables are allocated. Basically, these variables are allocated generally in any programming language. These variables are allocated on stack memory. So what is the specialty? Have you ever gone through something called Stack Overflow errors? If you go through something called Stack Overflow errors, you can understand. Stack Overflow is something, it gives Stack Overflow errors. What is called Stack Overflow error? For every application that you create, stack memory is allocated. Sorry, every application that you run, stack memory is allocated. How much stack memory? Does anyone know about it? The stack memory is static amount of memory. It is not like unlimited amount of memory you get it. Generally 2 MB. I think on Windows machine it's only 1 MB. Some machines, if they set up it, you may get even 4 MB or 8 MB, but generally the standard is 2 MB. So you cannot increase the memory, you cannot decrease the memory. That is a static memory. So whatever the local variables you create, generally these are stored in static. Why I said the word called generally, I tell you. So these four variables are stored in static memory. So what is the size of static memory? 2 MB. Does it increase the size? No. As long as your application is running, you don't change anything in your operating system settings. The standard size of static memory is 2 MB. That means all the local variables. Stack frames are whenever you create a function, it creates a stack frame or generally stored in stack memory. But what about the heap? So what is so you see that this the size we cannot say how much the code segment you have. This we cannot say because you can create any number of constants or global variables assigned or unassigned. This is unassigned. I think this is into BSS. This is a constant. So all three of them are ultimately into data segment. What inside the data segment is it a read-only data segment? Yes, this is called RO. Most probably this is called BSS. It's a subdivided into different parts. Unassigned, constant, read-only. But ultimately it's a data segment. Okay, this is the data segment. So stack memory is only 2 MB. You cannot get it more when your application is running. But what if I want a lot of memory? This is where heap memory comes into the picture. Unlimited amount of memory during runtime. Runtime means when your application is running. Is it really unlimited? Depends on availability and other OS factors. Generally, there are some allocators like vmem. I forgot virtual memory allocator. There are some heap allocators. There are some allocators like MLOC functions internally that are run by your operating system. They give you heap memory. How much heap memory? Yes, unlimited amount of. Is it really unlimited? Yes, it depends on as long as you have available memory. Unlimited means it's not a water of ocean. Obviously, every application, every system has got limited amount of memory. Within that limited amount, yes, you can have unlimited. You go to a hotel, they say that you can eat unlimited amount of rice or unlimited amount of rotis. Yes, you can eat, but still there is a limit. You can say that I'm going to eat 1,000 rotis, though no one can eat, but just telling you. No, you cannot because they might have not made 1,000 rotis. Within their limitation, you can eat maybe 4 5 rotis or 10 rotis. That's fine. Or some kind of amount of rice. Unlimited is very tricky word. From where it gets the memory? From your operating system. From where operating system gets the memory? From your system, from your hard disk, or from your RAM. Generally, it is from hard disk, virtual memory. Then it is converted into RAM, which we call it as the process of swapping. So, and the tricky part in Go is if you are into Java, C++, etc., you might know one thing. Objects are created in heap, variables are created on stack, static variables are created in data segment. Sometimes constants are also created in code or text segment. Old programming languages used to create constants are created in text segment. That means they embed the constant, but later on it got changed, as far as I see. But in Go, what should be stored in heap memory, what should be stored in stack memory is decided by your compiler. It doesn't mean that 100% this got to be stored in stack memory. So in Go, variable Whether a variable is stored in stack or heap is decided by compiler. There is a concept called escape analysis. So this is stored in stack memory. At a blind eye, yes, it is. Is it really true? I don't know. Let's say I create, even though we have not discussed about our arrays, where array 1 is 10 of integer, where array 2, we will discuss about arrays, just telling you, array 2 of some number, which is array. So my gut feeling is this is stored in stack, this is stored in heap. Why? Both of them are arrays. But what Go compiler think is 10 is a small number. And there is an algorithm that runs whenever you compile your application. So let me store it in stack. Array 2 is a again an array, but it's a very big array. So let me store in heap memory. For your understanding, print line of array 1 and print line of array 2, go run. It is unable to print. fmt.println of array 1, fmt.println of array 2. You see, it is taking a lot of time to allocate the memory, the runtime. It's a massive amount of memory, massive amount of memory. So the operating system is taking a lot of time. It's not about compilation, it's about running. Remember that. It's not about compilation, it's all about running. Even the output is unable to print such a big number. Okay, let me do one thing. Instead of printing this, let me put the length of this, which is going to give you the length of this. We'll discuss about it. I'm just giving you some example with respect to what the stack heap and all. So array 1 would be created on stack, array 2 would be created on heap memory. How do you know it is on heap memory? You can see that this is the size, this is the length. It takes little time because it's a massive amount, massive size. I want to know the address you understand, even though we are little ahead of, for you to understand address of array 1 of 0. I do the same thing, address of array 2 of 0. I'm just telling you, you see that same change in addresses. This is the address, last letters, these are the different address. So you can think of there are two different memories. There is a separate way to do that, which we call it as escape analysis. I'll explain. But I'm just telling you, okay, where the memory is allocated, it purely depends on the compiler that decides, unlike other programming languages. The last one, you see that A and B, 10 comma 20. I want to swap a variable, the value of A to B, B to A. You can see a temporary variable, T is B, B equal to A equal to T. This is what generally we do. We have A and B. I want to swap the value. This is what we do. But in Go, you don't need to do this. If you print A comma B, you would see that it prints the value of A and B, 20 and 10. But in Go, you don't need to use the temporary variable. A comma B equal to B comma A. That's it. you would see that even if you print it again, it prints back to 10 and 20 because it reswapped. It's not confined only to two variables. Even you can do with three variables. I have ABC, A1, B1, C1, three variables. I want to swap A1, B1, C1 equal to maybe B1, C1, and A1. This is a swapping. Print line A1, A1 is A1, B1 is B1, C1 is C1. So A became 20 because B value we gave, B become 30 because C value we gave, and C1 become A 10 because A value we gave. So the swapping is pretty easy. You don't need to create a temporary variable and all. It's a very fast swapping. I think most of the processors support this swapping without performing a lot of operations. Okay, this is how the variable creation and also what you need to understand from here is to summarize. There are four segments of memory: code, data, stack, and heap. Code and data are allocated during compile time. Stack and heap are allocated during runtime. Your entire code would be stored in code segment. The global variables and constants are stored in data segment. Normal variables within a function are stored in stack memory, but if the Go escape analysis think that it is not supposed to be stored in stack memory due to XYZ reasons, which are algorithm related reasons, algorithm decides it would store in heap memory. Unlike many programming languages, a object is stored in heap, variable is stored in stack. It is not like that for Go. Go has a different memory model. Whether a variable is stored in stack memory or heap memory is decided by the compiler by running some algorithm. That algorithm we call it as a escape analysis. Okay, we will go more and more deeper into that. I just don't want to explain how to create variables, but I want to show you as well. I will also show you how these are all created in data segment, how these are all created in code or stack, memory, and etc. In going forward. Okay, uh, you can also build your application and all. We will discuss about the other things in the next session. Probably, if you all agree, on a weekend we will go for 3 4 hours of a session so that we can spend more time. I don't want to stick only to 40 or 50 hours. It's all about I want to give you the knowledge as much as possible. So I know that the time that I gave is 40 to 50 hours, but sometimes it go beyond that because we are going to look into the minute details of each and everything, internal details of each and everything. It may go beyond 40 hours. No worries. We can spend some time. So any weekend we can spend. If anyone is not able to understand, obviously there are recordings as well. I wish, obviously I will take your consent to go for that. Voting we can go for and all. Yeah, thank you very much. That's all for today's session.